I'm sure you guys are pissed off of React seeing everywhere just like me, but let's understand the React compiler that may or may not help you. So I saw this article and will use it for making you understand the React compiler concept, but let's know about some terms like transpiler, compiler, and optimizer before we go. So a transpiler is a program that analyzes your code and outputs functionally equivalent code in a different programming language or an adjusted version of your code in the same programming language. It converts JSX to the code that is actually run by a JavaScript engine. For example, if you wrote this code using JSX, this is the code that is actually sent to the browser, not like HTML syntax, but nested function calls passing plain JavaScript object that React called props. So what's the difference between a transpiler and a compiler? Well, it depends on who you ask and what's their background, experience, and education. If you come from a computer science background, you might have mostly been exposed to compiler. The important thing is to understand that transpiler and compiler and optimizer a program that take text file containing your code, analyze it, and produce a new text file of different but same functionality code. What React compiler does, it creates code functionally equivalent to what you wrote but wraps bits of it in calls to the code the React folks wrote. When we say your code is analyzed, we mean the text of your code is parsed character by character and the algorithm are run against it to figure out how to adjust it, rewrite it, and add feature, etc. In the case of React compiler, it utilizes both an AST or an intermediate language to generate new React code. It's important to remember that React compiler, like React itself, is just another people's code. When it comes to compilers, transpilers, and optimizers, and don't think of these tools as mysterious black boxes. Think of them as things that you could build if you had the time. Before we move on to the React compiler itself, there is a few things that you need to know. Remember that we said React's core architecture is both a source of its popularity but a potential performance issue. We saw that when you write JSX, you're actually writing nested function calls, but you're giving your functions to React and it will decide when to call them. Let's take the beginning of a React app for dealing with a large list of items. Let's suppose our app function gets some items and our list function processes and shows them. Our function returns plain JavaScript object like a UL object which contains its children. Ultimately, React will build a tree from these objects called the fiber tree. Each node in the tree is called a fiber or fiber node. React actually keeps those branches that can fork from each node of the tree. React will then compare those two trees to decide what changes need to be made to the actual DOM. It's called reconciliation. A solution in programming to deal with the repeated calls to expensive function is to cache the result of the function. This process is called memoization. If I say React uses a structure called hook storage, then you'll say, come on Adi, we know that React uses hook storage to manage and cache the state and side effects for functional components. This helps to optimize the performance by reducing unnecessary re-renders and recalculation. The React app will render and interact with a list of items. Suppose we will eventually store selected items, process the item client side for rendering, handle items, and sort the list. What is really happening here? The use state and the user lines are executed by JavaScript engine. The node of the fiber tree created from our list component has some more JavaScript objects attached to it to store our data. Each of those objects is connected to each other in the data structure called linked list. Oh, do we got PTSD? By the way, a lot of dev thinks use state is the core unit of state management in React, but it is not. It's actually a wrapper for a simple call to use reducer. Ultimately, hooks are just objects designed to hold data in user's device memory. React combines the idea of memoization and it's the idea of hook storage. You can memorize the result of the entire function you give React that are the part of fiber tree or individual function you call within them. Program that analyzes the text of your code and produces new code ready for JSX transpilation. Let's see what React compiler actually does to our app. The C function, think C for cache, creates an array that's stored using a hook. React compiler analyzed our link function and decided to maximize performance. We need to store things. When our function is first called, it stores results for each of those 6 things in that array. Entire work around process items, both calling the function and generating the list, is wrapped in the check to see if cache is the second position of the array is the same input as the last time of the function was called. React compiler code say if you give me the same list of items that was last time you call function, I will give you list of that is stored in the cache for the last time. See the T3 line? Rather than recreating the arrow function that returns the li, It stores the function itself in the fourth position in the cache array. In this way, React caches values and memorizes the results of function calls automatically. Transpiler converted the JSX into nested function calls. There is not significant difference between what you wrote and what JavaScript engine runs. If you use React compiler, that means you are saying just store as much as you can in your device memory, which can be, but that is the brief explanation of React compiler you can get best in the form. So don't forget to subscribe text, and I'll see you next time, and don't forget to comment your crazy ideas. Bye bye cuties.